Laws of physics are absolutely instrumental to how every particle in the universe behaves, from quarks all the way to neutrinos. The mass of these particles is pivotal to how they interact. But what gives all particles their mass? Before we answer this essential question, we should discuss why it's essential in the first place. In a nutshell, the mass of every particle is very important to how they interact. For example, photons, which are particles and waves at the same time, have absolutely no mass. This means they travel at c, or the speed of light. Another example of mass being crucial to the laws of physics is with groups of heavier particles, which are held together by both the strong force at a smaller level and gravity at a larger level. However, if their mass changed, they would interact completely differently, and they would have different gravitational pulls. So what gives these particles their mass in the first place? The answer to this massive question is the Higgs boson. Like all bosons, the Higgs boson creates a field. In this case, the Higgs field. This field spans across the entire known universe, engulfing every particle within it. After using a particle accelerator to smash particles together at extremely high velocities, the Higgs boson was discovered to add on to the 4 other bosons that are currently known. However, once the collision happened, they weren't sure what particle it was. After a few years, they discovered that it was most likely the Higgs boson, which was discovered by Peter Higgs back in 2013. But how does the Higgs field give elementary particles their mass? A good analogy to help us comprehend the Higgs field is a physicist's cocktail party. This analogy states that physicists from around the country gather for a cocktail party. If an average person were to walk through the crowd, he would get through quickly without interacting with the physicist that much. Meanwhile, if resurrected Albert Einstein were to attempt to walk through the crowd and get a cocktail, the physicist would be all over him, chatting about his breakthrough discoveries in the field. If this crowd was the Higgs field, the average guy would be like a photon. Because he didn't interact much with the Higgs field, he would move through it effortlessly. A photon is like this because it doesn't interact at all with the Higgs field, which is why it travels at such astounding speeds. In contrast, Albert Einstein would interact a lot more with the surrounding crowd, and it would take an eternity to get to the bar. Because he interacts so much with the crowd, we can say he's like a quark, which makes up protons and neutrons. Because quarks interact way more with the Higgs field, they have more mass than that of a photon. In a nutshell, an elementary particle that interacts more with the Higgs field has more mass than a particle that interacts less with it. That is how one of the most pivotal elementary particles in the universe functions. The Higgs field is one of the most distinctive traits that makes our entire universe the way it is. Thank you for watching our 3rd ever Dig Deeper video and our 1st ever video on the topic of physics. We decided to show you that we enjoy talking about more than just one field of science, so we went into some hardcore physics for this one. Put in the comments below some ideas for new videos and whether you liked this video or not. Show your support by subscribing to our channel and liking to all our videos. Thanks for watching, and remember, always dig deeper.